Hello everyone and welcome to the aTech channel. Today we're going to focus on the Japanese Army's air fleet. Indeed, Japan is flexing its muscles to make its mark, and it already has demonstrated its capabilities with its 6th generation aircraft, the F-2, and it aims to develop an even more powerful aircraft, the F-3. Among its main assets, the radar invisible patches and its speed will make it one of the fastest aircrafts. Japan's idea is to modernize its fleet of planes, which promises to be the most spectacular in the world within a few years. Japan was ruined after the Second World War. Two of its cities, Hiroshima and Nagasaki, were the only ones who received the power of the atomic bomb, but that was 77 years ago. The country then began the new era of military development with the purchase of aircraft from the new allied countries, until the United States blocked the export of the F-22. This was the beginning of the construction of the new Japanese fleet. They currently have F-2s but want to expand. Thus, it is planned that in 2024, they will release the prototype for the new F-3. The Japan Procurement, Technologies and Logistic Agency oversaw the construction of aTech, Advanced Technology Demonstrator. This is a scaled-down test aircraft that flew 34 missions between 2016 and 2017. Among these things, it provided much-needed data for engineers. The Japanese agency is focused on 14 other programs that are developing the technology needed for a stealth craft. This is with a focus on sensors, data links, and an optimized weapon port. In addition, they continue to develop the XF9-1 experimental engine. To do this, they've enlisted the help of Lockheed Martin, a foreign company that helped them design the F-3. These engineers proposed the new type of stealth fighter that would combine the features of the last aircraft in vogue. What the Japanese want for their F-3 is great stealth and weapons power. The aircraft must be able to carry more weapons than the F-35 while maintaining a long range of nearly 950 kilometers. The Japanese company Mitsubishi has been chosen to carry out this difficult task. Currently, the Japanese Air Force operates 350 aircraft, with a fleet combining F-4s, F-15s, F-35s, and F-2s. Japan wants no less than 112 aircraft in its fleet, so it'll need 107 F-3 aircraft. But there is a major economic obstacle. Japanese taxpayers will have to pay hundreds of millions of dollars. Indeed, this new aircraft does not have the economic of scale that will allow the creation of 195 units of the F-2. The Japanese newspaper Nihon Kaiza reported that the program will cost $48 billion. Nevertheless, the F-3 is scheduled to commercialize in 2035. The program seeks to integrate remote-controlled drones to escort the fighter pilot. Among other things, they'll have to integrate the VR-type helmet display and a microwave weapon-type radar. To neutralize enemy missiles in F-3, it'll be able to exchange sensor data and will have at least 6 massive weapons. To better understand the history of this fighter, a few words about the most mythical of them all, the predecessor of the F-3. The Mitsubishi F-2 is a Japanese fighter based on the F-16. It was developed in the mid to late 1980s and produced in the early 1990s by various Japanese and American industries. The aircraft is based on Lockheed Martin F-16 Fighting Falcon design and is optimized to protect Japan's sea lanes. Many of the aircraft's innovative systems, including the flight railway control system and the integrated electronic warfare system, were developed in Japan. It was also the first production aircraft equipped with electric active radar. In addition, the wing area of this model is increased by 25% compared to the F-6. Thus, the larger wings allow for more internal data storage and 2 more weapon storage stations than the F-16. To manufacture this aircraft, Japan uses graphite epoxy and applied advanced composite technology to maximize strength while minimizing weight. In addition to the fuselage area, the F-2 is 43 centimeters longer than the F-16. The characteristics of the program are the transfer of the technology and the sharing of the production between Japan and the United States, the former being responsible for producing 60% of the aircraft and the latter 40%. All Japanese development began when the United States, by decision of Congress, refused to sell Japan the F-22 Raptor, the most advanced aircraft of the late 20th century. Japan then turned to the local factories such as Mitsubishi. Currently in the development, the F-3 has a design of construction ahead of the American-British models, allowing the Japanese to develop their technology for components, afraid sensors, light frames, and information systems. Although no images of the F-3 are available, conceptual illustrations have been made of what it will look like when completed. Some rumors claim that it will be nicknamed Godzilla. From a technical point of view, we have an electronic operation control surface to maintain a low radar profile, and that space will be reduced inside the fuselage. Thus, conventional hydraulic systems will be used sparingly, if at all. It'll also feature a fiber optic light control system, the light pilot system, as well as snake-shaped air inlets to help further reduce the radar's cross-section in heat signature in flight. The F3 could feature heat shields and integrated composite bond structure, which would help reduce the overall weight of the aircraft, giving it a much wider range. As of 2018, it includes the new turbofan jet engine derived from the XF91 model. This includes materials that'll keep its weight down while increasing the heat tolerance up to 1,800 degrees Celsius. The engine is capable of pumping 16.5 tons of thrust with afterburners. While impressive, it still falls short of the 119 engines installed in the F-22. Other members of the project team, such as Toshiba and Fujitsu, will develop the characteristic radar system based on gallium nitride. The F-3 landing systems will be developed by the Baron Company, whose aerospace division builds the lounges and landing gear for commercial aircraft such as the Boeing 777. The evolution of the first-generation fighters are the aircraft that switched from the propeller propulsion to jet propulsion. They provided more speed and thrust than the rotor engine systems. These aircraft are divided into two groups: those deployed in World War II, such as the Me-262, and Major. Those were developed in the Korean War in the 1950s, such as the F-86. Second-generation aircraft are those that, in addition to being jet-powered, being deployed are more ergonomically wing fuselage. They're more famous for the American F-86 and the Soviet Me-15. The third generation consists of the American F-100, F-106, and the American Me-17 and Me-21 developed in the 1960s and 70s. All were equipped with invisible missiles and capable of supersonic speeds in F-4. Beginning in the middle of 1970s, the fourth generation of fighter aircraft was considered the best in the class worldwide. Then came the fifth generation with major advances that led to the emergence of the well-known model, the F-22 Raptor. These aircraft can be flown by humans or remotely if there are drones. Another particularity is that they have swarms of drones that can distort the aircraft with precision. Data fusion allows them for more complete analysis of the different situations generated for optimization. Faced with imminent threats from countries such as China and North Korea, Japan has been faced with the dilemma of generating aircraft that better defend its territory. To do so, it has to resort to the strategic alliance with Britain and American companies. But the world will have to wait until 2035 to see these engineering gems fly. If you enjoyed our topic of the day, feel free to like this video. To enjoy more videos like this, subscribe to the channel, and above all else, leave us suggestions for our next topic. Activate the notification bell to be among the first to see our next videos, and we hope to see you soon on aTech.